another essential topic in the field of water supply, EN Risk 188. The topic is the health risk assessment of water supply system. So this topic is particularly important because water is a fundamental resource necessary for life, and ensuring its safety is critical for protecting public health. Okay, so water supply systems are integrated networks designed to deliver clean and safe water to our homes, schools, businesses, and various institutions. These systems are crucial for sustaining daily life, supporting economic activities, and promoting overall well-being. However, they are also vulnerable to various contaminants and hazards that can pose significant health risks. Okay, so for this topic, we will cover a few subtopics. In this session, we will cover several key aspects of health risk assessment in water supply system. Okay, so for the first one is of course identification of hazards, where we are understanding the different types of contaminants that can affect our water quality. The second one is sources and pathway of contaminants, exploring how contaminants enter and spread within the water supply system. The third one is exposure and toxicity data, examining how exposure to contaminants affects human health and the data used to assess these effects. And risk characterization and management, learning how to evaluate risk levels and implement strategies to manage and mitigate these risks. Okay, and the last one is of course monitoring and surveillance of health protection. Discussing for this topic, we will discuss the importance of continuous water quality monitoring and surveillance system for early detection and response to waterborne disease. Okay, so for the first topic, identification of hazard in water supply system. The learning objective is by the end of the session, you all should be able to understand microbiological, chemical, and physical hazards in water supply system, recognize common contaminants and their sources, understand how contaminants enter water supply systems, and outline the steps to identify hazards in water supply system. Okay. For the introduction, ensuring the safety and quality of water supply system is critical for protecting public health. Okay, to the consumers, water supply systems can be vulnerable to a variety of hazards, including microbiological, chemical, and physical contaminants, which can pose significant health risks if not properly managed. Understanding these hazards, their sources, and their pathway is essential for effective risk assessment and monitoring management. Okay, so here for the introduction, this diagram illustrates the various sources of emerging contaminants in Malaysia. Okay, starting from the top. Okay, here from the top here. From the top left, factories and manufacturing processes release effluent, which are liquid waste, into the nearby water bodies, and these factories are significant sources of industrial chemicals and pollutants. Okay, in the top right here, the diagram lists potential sources of emerging contaminants, including cleaning detergents, pharmaceutical, pesticides, plastic waste, industrial chemicals, and personal care products. These contaminants originate from various activities such as manufacturing, agriculture, and household use. Okay, so from the water bodies, water is used for irrigation in agriculture, introducing contaminants into the soil and crops. The runoffs and waste from agricultural fields further carry pesticides and fertilizers back into the water bodies, exacerbating pollution. And households contribute to contamination through the use of cleaning detergents, personal care products, and improper disposal of pharmaceuticals. Wastewater from household flows into the main sewer lines, which lead to the wastewater treatment plants. However, not all contaminants are removed during treatment and some can end up back into the water cycle. While hospitals also generate waste, including pharmaceuticals and medical waste, which can enter the water system through improper disposal and landfills. Additionally, hospital waste is directed to landfills where it can leach into the groundwater, posing further risks. The wastewater treatment plant treats the sewage and releases treated water back into surface water bodies and indirectly into groundwater. This treated water is then used for various purposes, including domestic use, which closes the loop in the water supply system. The circle demonstrates how contaminants from multiple sources can enter and spread through the water supply system, highlighting the need for effective management and treatment practices to protect water quality and public health. Okay. And pathways of contamination in water supply system can be from surface water pathways. Okay. Water from rivers and streams can become contaminated from runoff, industrial discharges, and also sewage. These water bodies can collect pollutants from the surrounding land, including agricultural runoff and urban storm. Groundwater also can be one of the pathways of the contamination in water supply system, where aquifers are underground layers of water-bearing rock or sediment. Contaminants can seep into aquifers from the surface through cracks and porous materials. Wells draw water from aquifers if the surrounding area is contaminated and pollutants can enter the well water. Distribution system pathway, for example, pipe leaks and breaks where contaminants can enter the water supply through leaks or breaks in the distribution pipes. Cross connections, where the improper connections between potable drinking water supply and non-potable sources can lead also to the contamination. Storage tanks, if storage tanks are not properly maintained or sealed, contaminants can enter the water supply from the environment. Okay, so here are next adalah steps to identify hazards in water supply system. Okay, so for the first step, preliminary assessment, where we review existing data on water quality, where the goal is to understand the current state of the water supply system by examining existing data. This involves collecting and analyzing historical data reports related to water quality. Sources of data may include the water quality monitoring records, laboratory test results, reports from local health departments or water authority, data from previous inspections and assessment. Okay, so for identifying any patterns, trends or recurring issues in water quality and to developing a comprehensive list of potential contamination source, targeted inspection and intervention. Okay. The third one is laboratory analysis, where we conduct field surveys and site inspection to visually and physically inspect various points within the water supply system for potential contamination sources and vulnerabilities, where the methods is field surveys, inspections and documentation. Then we collect water samples from various points in the supply system, where we gain a true understanding of the current state of the water supply system. Okay, after that, the laboratory analysis, where to identify and quantify contaminants present in the water sample collected from various points in the supply system, utilizing established protocols and procedures from organizations such as EPA or WHO. Or in Malaysia, we can follow the National Drinking Water Quality Standards by Ministry of Health. these implementing measures to verify the accuracy and precision of the test results. Okay, so that's all for the summary. Health risk assessment of water supply system involve identifying microbiological, chemical and physical hazards and evaluating potential health risks using data review, site inspection, laboratory analysis as well as risk assessment methods. The objective is to ensure safe drinking water by systematically addressing contamination sources and implementing monitoring and mitigation strategies. Okay. For more information on identifying microbiological, chemical and physical hazards have been discussed in the previous lecture. You may go to the feature and check the other topics that have the microbiological, chemical and physical hazards. Okay, so for that, thank you everyone. See you in the next lecture. Thank you. Bye.